Hello everyone, welcome to Smarter Insights into the Mains Answer Writing program by Bajirao Ias Academy. And you all knew that we have been discussing the detailed answers for the mains questions which were asked in 2025 mains examination. And in fact, today also we have some questions from General Studies paper 3 that covers economy, Indian agriculture, disaster management, science and technology and internal security topics. So let's discuss these questions in a detailed and in-depth manner as part of the Smarter Insights into the Mains Answer Writing program. And the first question is, the fusion energy program in India has steadily evolved over the past few decades. However, mention India's contributions to the International Fusion Energy Project, International Thermonuclear Experimental Reactor. And if we talk about International Thermonuclear Experimental Reactor, so it is a fusion energy program worldwide. And what will be the implications of the success of this project for the future global energy? Now, global energy security is very important because of the growing demand for the energy. Now, in this context, what should be the model framework of this question? The model framework, in the introduction, you need to briefly write about the International Thermonuclear Experimental Reactor. And in fact, it is a energy fusion or fusion energy program, and that aligns with clean energy goals and the scientific advancement also. And in the body part of the answer, you just mention the critical components and expertise to the International Thermonuclear Experimental Reactor and how India contributes in terms of providing expertise and also critical components. And next, you need to write about the cryostat and diagnostic support that India has provided to the International Thermonuclear Experimental Reactor. And then you need to talk about the project's success and how can this revolutionize the global energy with abundant, clean and safe fusion power, enhancing the energy security. Now, most of the nuclear energy programs that we have so far are how nuclear energy produced in most of the countries or throughout the world is through the nuclear fission. However, nuclear fusion is not yet feasible way of energy generation. However, the International Thermonuclear Experimental Reactor has been exploring the possibilities of generating electricity or energy through the fusion reactors. And if it is successful, then it could successfully meet the global energy demand and it ensures the energy security throughout the world as well. And in the conclusion of this answer, you need to write about the need for sustainable global energy and India's scientific leadership that guides the International Thermonuclear Experimental Reactor and the program's overall success in achieving the fusion-based nuclear energy generation. So this is how you need to write the conclusion in a positive and optimistic manner. As I've already told you that firstly, you just mention about the International Thermonuclear Experimental Reactor and India's contribution to the International Thermonuclear Experimental Reactor in brief, so that the examiner will understand what exactly is the nuclear fusion reactors or International Thermonuclear Experimental Reactor. Now, in fact, India has been aiming to achieve clean and sustainable energy. So we are not just focusing on the energy security, but we are also focusing on generating clean and sustainable energy. And this led to actively participating in the global nuclear fusion research. However, one of the key involvements in the India's involvement is International Thermonuclear Experimental Reactor. So this is India's one of the key involvement. And in fact, this is world's largest nuclear fusion experiment, which is based in France as of now. So I have already talked to you explained you that the fusion based nuclear reactors, they generate more amounts of energy and they will also meet the global energy demand, and they could also ensure the global energy security as well. They could also ensure global energy security. And that's why the International Thermonuclear Experimental Reactor is very, very important. Understand and remember, this is a fusion based reactor. And apart from that, the other advantage is that the energy generated from the nuclear power plants is considered as close to clean energy because it generates a very less emissions also. So therefore, in this context, the International Thermonuclear Experimental Reactor is very important, and India's contribution to the nuclear fusion reactor program is much more important. I hope you have understood this International Thermonuclear Experimental Reactor and other details with respect to the International Thermonuclear Experimental Reactor, including it is located in southern France and it is a collaborative effort, and that involves more than 30 countries. And these 30 countries have involved in this particular program to prove the feasibility of the nuclear fusion at a large scale and the carbon free energy source, because I've told you that it results in lesser emissions when we generate electricity through the nuclear power plants, whether it is nuclear fusion or nuclear fission. So as of now, we would like to generate electricity which is clean, green and also environment friendly. For example, the major chunk of India's energy is produced through coal, and coal is a fossil fuel. And if you burn fossil fuel, it emits a lot of greenhouse gases into the atmosphere. So when it releases a lot of greenhouse gases into the atmosphere, India will not be able to meet its existing climate goals. So therefore, we have to meet our climate goals and we need to generate energy which is environment friendly, clean and green as well. So therefore, 30 countries have involved in this International Thermonuclear Experimental Reactor, which involves the nuclear fusion as a method. Right? So let's understand the nuclear fusion principle. It fuses the light atomic nuclei. So there are two light atomic nuclei. They come together to form a big or heavier nucleus. Right? So this is the principle which is used in the nuclear fusion reactors. However, this is under development since 2005 and it is expected to begin deuterium and tritium fusion reactors or reactions by the year 2039. Right? So funding structure: European Union, which is currently the host of International Thermonuclear Experimental Reactor, it has been contributing currently 45% and other countries have been contributing 9%. Right? And in fact, the International Thermonuclear Experimental Reactor was established in the year 1985 and it actually involves 7 core members: India, European Union, South Korea, US, Russia, Japan and China. So all these countries are core countries. However, more than 30 countries have involved in the International Thermonuclear Experimental Reactor nuclear fusion program. So I hope it is clear for you, right? Now let's understand the body part of the answer, because we have asked a question about India's contributions in terms of expertise and in terms of various other support system that India has been providing for the International Thermonuclear Experimental Reactor. And always remember to divide the question into number of component parts and address each of these component parts with relevant examples and data. Now, if you look at India's contributions to the International Thermonuclear Experimental Reactor, India is known as a strategic partner, and India is also contributing to the International Thermonuclear Experimental Reactor in terms of providing technological support and India's financial commitment. India also providing human resources expertise and even the cryostat as well. Now, if we talk about the strategic partners, we have just understood that there are 7 core countries which are part of the International Thermonuclear Experimental Reactor. And among these 7 countries, India is one of the core country and it is also a strategic partner to the International Thermonuclear Experimental Reactor. So why? Because India is a founding member of the International Thermonuclear Experimental Reactor. So these 7 core countries are the founding members of the International Thermonuclear Experimental Reactor. So along with India, European Union, USA, Russia, Japan, China and South Korea. So all these countries are the founding members of International Thermonuclear Experimental Reactor. So along with being a core country, India is also a strategic partner with the ITER. So I hope you have understood the first point. And second point, the technological contributions that India has been making for the success of International Thermonuclear Experimental Reactor. So let's understand this as well. Now, through the Institute for Plasma Research, India has been providing critical components to the International Thermonuclear Experimental Reactor program. Right, so this contribution is provided through Institute for Plasma Research. For example, let's understand what critical components that India has been providing to the ITER. So firstly, the cryostat is provided by India. Now what is this cryostat? It is world's largest steel vacuum chamber, and this world's largest steel vacuum chamber has been built by Larsen and Turbo, and it has been provided by India to the ITER. So this is the first component that India has provided in terms of the technological support. And apart from that, it has even provided the cooling water systems as well. Right, so as part of the ITER, the nuclear fusion takes place at extremely high temperatures. So therefore, there is a need for the cooling water systems, and India provided the cooling water systems and in-vessel shielding and even the diagnostic systems also. So therefore, India has been providing the critical components to the International Thermonuclear Experimental Reactor as a core country and a founding member of ITER. And apart from that, if you look at the financial contribution of India for this ITER project, now India contributing approximately 9% of the total ITER project cost. Right, so this is partly in cash and partly through the in-kind contributions. Right, so therefore India is also strongly providing or committed for providing funding to the International Thermonuclear Experimental Reactor, and that's how India is called as the strategic partner or core and founding member of the International Thermonuclear Experimental Reactor. So apart from that, the other important contribution that India has been making for International Thermonuclear Experimental Reactor is providing the human resource support and relevant expertise also. Right, because in design, research and development, delivery of high-tech systems, the Indian scientists and engineers are involved. Right, so therefore the government has also been providing human resource and expertise for the success of International Thermonuclear Experimental Reactor. So however, let's understand some implications of ITER's success, because as a second component, this is also asked in the question. Now if you look at the implications of ITER's success, so firstly, as I've already told you, that the fusion reactors have a lot of efficiency when it comes to generating energy at a lower cost, and in fact it can also ensure the energy security across the globe. Right, so it provides energy security, and it will also be able to ensure the energy demand will be met. So therefore there will be a clean and abundant energy. Now the other advantage is that through the nuclear fusion reactors there will be no greenhouse gas emissions, and apart from that, a minimal radioactive waste will be generated. So if minimal radioactive waste is generated, we could be able to dispose it in a safe and secure manner. So therefore the first implication would be clean and abundant energy. Secondly, energy security. So energy security is again another very important component of the International Thermonuclear Experimental Reactor. For example, fusion fuels like deuterium from seawater is very abundantly available. So therefore, it can help us reduce our dependence on the fossil fuels. For example, coal is a fossil fuel, crude oil is also a fossil fuel, natural gas is also a fossil fuel. Now what is the problem with the fossil fuels? When you burn these fossil fuels, they release the greenhouse gases into the atmosphere, and this greenhouse gases emissions would contribute to the global warming, and global warming in turn resulting in the climate change and the worst effects on the planet Earth. Right, so therefore it ensures energy security and clean environment as well. And thirdly, the technological advancements that we could achieve through the International Thermonuclear Experimental Reactor. For example, the spin-off technologies including the material science, superconductors, cryogenics, and the robotics as well. Right, so therefore a multifaceted, right, so a multi-sectoral or a multifaceted benefits or a multiplier effect, I would better call, right? So once we develop technology through the International Thermonuclear Experimental Reactor, so that will have a multiplier effect. So that is going to have a multiplier effect. And apart from that, we need to talk about the global cooperation model as well, because the International Thermonuclear Experimental Reactor is a collaborative program between more than 30 countries. So therefore, don't you think that it has been indicating the global cooperation model? So therefore, it demonstrates the potential of science diplomacy in solving shared global challenges as well. For example, climate change is an area where it requires the global cooperation model, and plastic pollution, it also requires the global cooperation model. So therefore, it actually set a strong precedent, a good example for the strong global cooperation to deal with the issues. Now ultimately, in the conclusion, what you have to write. So in the conclusion, India's proactive role in the International Thermonuclear Experimental Reactor reflects India's commitment to sustainable energy. We are remain committed to green, clean and sustainable energy, and we would be remain committed to the high-end energy as well, research as well. However, the success of ITER, so this will be considered as a paradigm shift in the global energy systems, because it will be able to meet the global energy demand and ensure global energy security, and at the same time substantially reduces the global greenhouse gas emissions and makes the energy generation green and clean. So therefore, this sustainable energy generation and this generation method will also help meet the global energy demand and ensures energy security, addressing the climate change associated challenges. So this is how you have to write the answer for this particular question. And next, understand this question is also related to the India's energy security, which is also being called as the energy independence. Now we all knew that by 2047, so India is going to celebrate the 100th year of its independence, right? So because of that reason, so by 2047, so we would like to become a Vikasit Bharat or a developed country by the year 2047. So on the similar lines, we also have the other objectives, other goals to be to achieve by the year 2047. Now this is asking, how can India achieve energy independence through clean technology by 2047? Right, so we need to achieve energy independence. That means we will not dependent on any other country for our energy supplies. So if I can mention one example, we have been importing 85% of the crude oil from other countries, and we have been importing close to 60% of the natural gas again from other countries. So therefore, in this context, Energy independence actually means that we'll be able to produce the energy that we needed, and the energy is produced through the clean technology by the year 2047. Now in this context, the first part of the answer is asking us that how can India achieve the energy independence through the clean technology, and first you have to address this part of the question, and then how can biotechnology can actually play a crucial role in this endeavor of becoming energy independent through the clean technology by the year 2047. So as I've already told you that this question has two parts, and it is important for you to address these two parts in the question. Now in the introduction of this question, first of all, you need to briefly talk about India's goal of becoming energy independent by the year 2047 through the clean technology. Right, so first you have to briefly introduce this, and in the body part of the answer, as I've already told you that it has two parts, two components. So first you need to address this part of the answer, and then you need to address the second part of the answer with relevant examples and data. And in the conclusion of this answer, as this question has been emphasizing on biotechnology, so therefore you need to integrate the biotechnology with clean technology, so that will ensure India's energy transition to a low carbon, energy secure future. So this is how conclusion should always be positive and optimistic in its outlook. Now in the introduction, as I have already told you, that first of all you need to talk about the energy independence that India aimed to achieve by the year 2047, and how India wanted to achieve energy security through the clean energy or the clean technology. So clean technology will be used to achieve the goal of energy independence by the year 2047. However, this goal is also aligned with India's target of becoming net zero by the year 2070. Right? So if you look at Prime Minister Narendra Modi's 5 pledges, one of the pledge is becoming the net zero by the year 2070, including biotechnology. Right? So we can achieve this energy independence through critical components like biotechnology as well, because the biotechnology has the potential to enable a shift from the fossil fuel dependence to sustainable domestic energy solutions. So therefore it will support economic growth and the environmental security also. So this is how you have to write a brief introduction in the answer. So make sure that this introduction is suitable to the demand of the question, and at the same time intro is also specific. Now let's understand the 5 pledges that Prime Minister Narendra Modi made, and these 5 pledges are also very important. Now first, these 5 pledges were made by Prime Minister Narendra Modi in the Glasgow summit of COP27. In COP27, Prime Minister Narendra Modi made these 5 pledges. Now we'll also understand what exactly is a net zero, because we would like to become net zero by the year 2070. Now net zero actually means the balance where emissions of greenhouse gases are offset by the absorption of the same amount of the greenhouse gases that are emitted. Right? So it is actually the balance where the emissions of greenhouse gases are offset by the absorption of an equivalent amount from the atmosphere. So whatever greenhouse gases that a country generates, the same amount of the greenhouse gases are being absorbed through oceans, afforestation methods, carbon sequestration. So all these methods, what you will do, there will be adequate mechanism for the absorption of an equivalent amount of the carbon dioxide from the atmosphere. Right? And in fact, it is being said that net zero is a critical measure to successfully tackle the climate change and its devastating consequences throughout the world. Now let's understand Prime Minister Narendra Modi's pledges with respect to the climate change. Now as per Prime Minister Narendra Modi, India will increase its non-fossil energy capacity by 500 gigawatt. So by 500 gigawatt, India will increase its non-fossil energy capacity. Secondly, India will meet 50% of its energy demand from the renewable energy resources itself. For example, wind energy, solar energy, so all these different forms of energy. And third important goal is that India will reduce the total projected carbon emissions by at least 1 billion tons. By at least 1 billion tons from now to 2030. From now to 2030. And then by 2030, India will reduce the carbon intensity of its economy by 45%. And in fact, it is a 10% higher than the previous target of 35%. And again, by 2070, India will become net zero. So net zero refers to the balance between the total amount of the greenhouse gases generated and the total amount of the absorption of the greenhouse gases. So whatever amount of greenhouse gases that are being generated, the same amount of the greenhouse gases are being absorbed from the atmosphere, and this is known as net zero. Net zero is critical and important to deal with the climate change. Now, if you look at the pledges by the top 3 emitters around the world, so China is the top emitter of the carbon or top emitter of the greenhouse gases. So China announced no new pledges. It previously pledged that it will become net zero by the year 2060, right? So US pledged to become net zero by the year 2050, but it is largely unpredictable because of US President Donald Trump. However, India firmly committed to become net zero by the year 2070, right? So these are the commitments made by the top 3 emitters around the world. So let's understand the body part of the answer. So what are the pathways to energy independence through clean technology? So there are some pathways to energy independence, right? So these pathways also use the clean technology as an element. So firstly, expansion of the renewable energy, because as per the 5 pledges made by Prime Minister Narendra Modi, we would like to generate 500 gigawatt of non-fossil fuel capacity by the year 2030. So fossil fuels will not be used when it comes to generating 500 gigawatts of renewable energy. And then the solar energy, so 100 plus gigawatt of solar energy will be produced, plus 40 plus gigawatts of wind energy will also be produced through this. And then we have to talk about the green hydrogen mission. We need to talk about the green hydrogen mission. This green hydrogen mission was launched in the year 2023. The objective of this green hydrogen mission is to produce 5 million metric tons of green hydrogen per annum by the year 2030, and to make India a major green hydrogen export hub in the world. Now, hydrogen energy is also a renewable energy that will not release any emissions into the atmosphere. So this will be the second most important pathway. And then we need to talk about the electric mobility and energy storage as a method. Already the government of India launched FAME program, right? So faster adoption and mobilization of electric vehicles, known as FAME program. And this FAME program will promote the adoption of the electric vehicles plus the battery storage systems, right? So in order to promote the electric vehicles and battery storage systems, this FAME program has been launched, and this FAME program aimed at substantially reducing the oil imports of India. Remember, as I've already told you, that India has been importing around 85% of the crude oil and 60% of the natural gas from the other countries. So therefore we need to reduce this dependence. And in fact, through programs like FAME, we have been focusing on lithium ion and solid state batteries as well. Then we need to talk about the smart grids and the energy efficiency as methods. So in fact, the use of Internet of Things and the artificial intelligence as a new technologies for the development of smart grids or management of the smart grids, because with the use of technology, it will reduces the transmission losses when it comes to the transmission and distribution of the technology. There are initiatives like PAT, Perform, Achieve and Trade. So the scheme that has been launched to enhance the industrial efficiency. This scheme has been launched by the government of India. And then we need to talk about the second component of the answer, which is role of biotechnology in clean energy. So this is the second component of the answer. Now, in fact, the biofuels can be produced through the biotechnology, right? Because the government has already mandated 20% ethanol blending by the year 2025, and it is also known as E20 policy. So E20 policy aimed at blending of 20% ethanol into the existing conventional fuels so that it can reduce our dependence on import of fossil fuels. Secondly, the biotechnology enhanced enzymes, microbes, so they can convert the existing biomass, algae and even waste into the biofuels. So the biofuels can be used. Now firstly, the solid waste management will be done, and from the solid waste management what we can achieve is biofuels as well, right? So how these biofuels can be produced? They can be produced through the use of enhanced enzymes and microbes. They are produced by the biotechnology because they can convert the existing biomass and algae and other waste into the biofuels as well. And apart from that, we should also talk about the waste to energy as an element as well, because biotechnology has applications in the waste to energy domain as well. Anaerobic digestion technologies using the biotechnological methods for biogas production from the organic waste as well. So this is also another most important and a very famous method of generating biofuels. And the carbon capture technology via biotech, right? Because the algae based carbon capture and utilization CCU systems, they can efficiently absorb the existing CO2 and they can also produce the bio oil as well. And then the sustainable agriculture for the energy crops, for example the genetic modification of high yield low input energy crops like jatropha and miscanthus, so they can be efficiently used for the energy generation. They can be efficiently and effectively utilized. And in the conclusion of this answer, what you have to write: so achieving energy independence by the year 2047 through use of clean technologies or multi-pronged clean tech strategy, which is required or which is the need of the hour. However, with biotechnology serving as a critical enabler, a synergy of innovation, policy, investment, so a multi-sectoral or multi-stakeholder approach will drive India towards self-reliance, self-sufficiency when it comes to producing sustainable energy resources for the future. So this is how you have to write the conclusion for this answer. And next question is about carbon capture, carbon utilization and storage technology. Remember, this question also has two important components. So firstly, you need to explain what is carbon capture, carbon utilization and carbon storage. And in the second part of the answer, you need to write the potential role of carbon capture, carbon utilization and storage in tackling the climate change. And you could briefly mention the existing challenges in the carbon capture, utilization and storage technologies. Right, so this is how you have to make the answer multi-pronged, right? So, or a holistic and a comprehensive answer. Now, in the introduction, so you just mentioned what exactly is carbon capture, utilization and storage. So CCUS involves capturing CO2 emissions, utilizing them in products and then storing them underground to prevent the atmospheric release of the carbon dioxide. So therefore it will help tackle the problem of the greenhouse gases and climate change. And in the body part of the answer, again I told you that you need to address the first part. First explain what is carbon capture, utilization and storage, and in the second part of the answer you need to mention the potential role of CCUS in tackling climate change, plus you need to briefly write the existing challenges in carbon capture, storage and utilization. For example, a lack of technology is a challenge, right? And apart from that, economically not feasible, so this could be another major challenge. So you need to write the number of challenges, and ultimately you need to link CCUS with achieving the target of net zero and also combating the climate change as well. Now in the introduction of this answer, as I've already told you, that you have to briefly talk about the carbon capture, carbon utilization and storage technologies, right? So it actually refers to the technologies that can capture the carbon dioxide emissions from the industrial processes. Now imagine that there is an industry, and from this particular industry the carbon emissions are generated. These carbon emissions can be effectively captured. Carbon emissions can be captured, and then these carbon emissions can also be stored in a specific way, so that these carbon emissions will not be released into the atmosphere, because that will cause global warming. That may cause global warming and climate change as well. So therefore, whatever carbon that has been generated from the industries will be captured. If needed, it will be utilized, and then it will be safely stored in certain areas, like for example underground coal seams, mined areas. So in all these areas it can be safely stored, right? So it can be used for useful products, processes, and stored in underground geological formations, right? So in fact, we all knew that countries have been aiming to become net zero. For example, India aimed to become net zero by the year 2070. China aimed to become net zero by the year 2060, and several European Union countries aim to become net zero by the year 2050. So in this context, the carbon capture, utilization and storage offers critical tool in managing hard to abate carbon dioxide emissions, and it can also effectively and efficiently support the climate goals of the countries as well, becoming the net zero. Now in the body part of the answer, what you need to write? Now firstly, you need to write the components of carbon capture, utilization and storage, right? For example, if we talk about the capturing of carbon dioxide, now in fact CO2, carbon dioxide, is separated from flue gas of power plants, cement, steel industries, and it captured directly from the air. So first we capture the carbon dioxide directly from the air, which is emitted by the industries in the first step, and in the second step the very same carbon dioxide can be effectively utilized to produce synthetic fuels, chemicals, carbonated beverages, or even for enhanced oil recovery. So therefore, the carbon that we have captured have multiple other applications also. So therefore, we can use for synthetic fuels production, chemicals, carbonated beverages, or for the enhanced oil recovery also. And then we should also talk about the storage component. Now the carbon dioxide that we have captured from the industries, from the industrial emissions, so this CO2 can be injected into the deep geological formations such as depleted oil and gas fields or saline aquifers for the long-term sequestration, right? So that it can be safely stored, and it will not released into the atmosphere, right? So these are the three components of CCUS, and let's understand how CCUS will help tackling the existing climate change, how it will help. Now firstly, it will help mitigate industrial emissions. There are a lot of industries, for example cement industry, steel industry, fertilizer industry, and these industries are also known as carbon intensive industries because they emit a huge amounts of carbon into the atmosphere. So however, the CCUS technology can be used for decarbonizing sectors like cement, steel and fertilizers, which are hard to electrify first. For example, Norway's Longship project, it aims to capture and store 1.5 million tons of CO2 every year. Then we need to talk about the negative emissions as well, right? So they are being coupled with the bioenergy, the carbon capture, storage and utilization. So it can deliver net negative emissions by removing CO2 from the existing atmosphere. So it will help achieve net zero targets of several other countries. And apart from that, it can also complement the renewable energy transition as well, because it will help manage the residual emissions during the transitional phase of 100% renewables. And if we talk about the India's potential, India, the third largest emitter globally, it emits over 2.9 billion tons of CO2 every year. And in fact, Niti Aayog has rightly identified the carbon capture, utilization and storage is a crucial method for achieving India's goal of becoming net zero by the year 2070. So I hope you have understood the important applications of the carbon capture, storage and utilization. Now in the conclusion, you need to write that the carbon capture, utilization and storage, so it is not a silver bullet, it is not a panacea for the problem of climate change, but it is a very important and a critical enabler for the global climate strategy, particularly decarbonizing heavy industries, steel industry, cement industry and other industries. However, there is a need for a policy support, investment and innovation. So with all these elements, the carbon capture, utilization and storage can significantly aid in and world limiting the global warming to below 2 degrees Celsius. Now in fact, the COP21 Paris climate deal, it aimed to limit the global temperatures by 2 degrees Celsius maximum, and if possible limiting the global temperatures below 1.5 degrees Celsius. So therefore the carbon capture, utilization and storage is a very important method to achieve this objective of limiting global temperatures by 2 degrees Celsius, if possible 1.5 degrees Celsius also. Now that's all in this session, and thank you so much. So please like a video and also subscribe our YouTube channel. Thank you so much.